Welcome back to our adventures in electrochemistry. New thing for us today. The question comes up of where did we get our redox table? And the answer is people figured it out by looking at different metals and trying them in different combinations to see what reacts and what doesn't. So what we have here is an experiment a person's doing where they take copper ions, zinc ions, lead ions, and silver ions, and then they try reacting them with the metals copper, zinc, lead, and silver. And the question is, what's going to happen if we do each of these things? So I'll start down here just for grins. If we take copper ions, copper 2, and we react them with silver metal, you can go to your redox table and find copper ions and silver metal. And I'm not going to drag the whole page in here, but basically the redox table has silver is the highest of these metals. And a little further down we find copper. Lower than that we have lead. And lowest of all of these four we have zinc. And you remember, we can tell if a reaction is spontaneous by the direction from the strongest oxidizer to the strongest reducer. A downhill arrow like this means the reaction is spontaneous, meaning it'll happen by itself. Just mix those chemicals and they'll go. Uphill like this means non-spontaneous, meaning those chemicals won't do anything when they touch. We'd have to give them a push with a power supply. So if we have copper ions, would have to be our strongest oxidizing agent. Silver metal is our strongest reducer, and because that goes uphill, it means this reaction is non-spontaneous, meaning no. Or you can write NR for no reaction. People do sometimes. So copper ions do not react with silver. Do they react with lead? Copper ions down to lead metal is downhill, so that one's spontaneous. That should be a yes. Do copper ions react with zinc? Here's copper ions, here's zinc metal. It's also below, so that should also be a yes. How about copper ions with copper? Well, we've said downhill is non-spontaneous, and downhill is spontaneous, uphill is non-spontaneous. From copper ions to copper is horizontal, meaning it's not spontaneous or non-spontaneous. It's right on the line between the two. But more importantly, what if it did react? Here's what you'd get. You'd have a copper ion meeting copper metal, and if that reaction occurred, this would take 2 electrons and become copper metal, and this would have to lose 2 electrons, becoming a copper ion. Overall, nothing happens. 2 copper atoms, one ionized and one not, exchange some electrons, but afterwards we have the exact same stuff, so there is no net reaction. In other words, we could say both of these things are spectators, cancel them out, and we would end up with nothing happening at all. So generally, we just skip entries like this on a table. The real answer is no detectable reaction. Even if electrons were exchanged, it wouldn't make any macroscopic difference, so we'll just ignore that. Now, I'll blow through the rest of these entries relatively fast. Zinc ions are lower than all these metals, so all these lines are going to be uphill, meaning they're all going to be non-spontaneous. So zinc is going to be no. We blip the one with zinc in it because, as mentioned, wouldn't matter. Zinc ions don't do anything. Lead ions are here. So lead ions can oxidize zinc. That one's spontaneous. So we'll get a yes on zinc. But we get a no for copper and a no for silver. And lead ions with lead, we blip that out. No reaction expected there, or no detectable reaction there. And silver ions are the very highest one. They'll react with copper and lead and zinc. So this will be yes, and yes, and yes. And we omit silver ions with silver for the usual reason. So notice the highest ion on the list gets 3 yeses. The next metal down, the copper, gets 2 yeses. Lead gets a single yes, and zinc doesn't get any yeses. You get more yeses, as in you react with more things when you're a stronger oxidizing agent. If you were way up here, you would react with everything because they're all downhill to you. And if you're a weak oxidizer like lithium, everything is above you, they're all non-spontaneous, and so your whole column is going to be no. So you can put metals in order just by seeing how many yeses they have on a table like this. So we completed the table, done. What happens when a metal is placed with its own ion? You get no net reaction. List the 4 ions in order, we have done that. We already had that from the redox table, but silver is the one most likely to become a metal because it's most likely to do its reduction reaction. Copper is second most, lead is the third most. Zinc has a lot of trouble turning into a metal because to do so it would have to react with something lower than it is. And there are only a few metals lower than zinc. Write a half reaction for what happens when each ion is transformed into a metal. Done. The redox table already has these. This note is just reminding you these things are wrong without the electrons. If you do this, I mean, I've done that as a shortcut, and maybe you have too, but technically this is not correct unless it has the electrons in it. So what this is warning you is you'll lose points if you forget the electrons in these reactions. Don't do that. What kind of half reactions did you write in D? Are these oxidations or are they reductions? My thinking is because the charge goes from plus down to 0, it's a reduction. The charge went down. The other way you can think of this is these atoms are gaining electrons. So that means either GR, gaining electrons, is reduction, or RIG means reduction is gain of electrons. Either way, these things are reductions. The metal ion that reacted with the most metals is the strongest. This is the ion that reacted with the most stuff. It's the silver ion. This is our strongest, what? Oxidizer or reducer? On the left side, these are the strongest oxidizing agent. So anything on the left side is an oxidizer. And on the right side, these guys are the reducers, the metal that reacted with the most things. If you look at this from the metals perspective, zinc metal gets 3 yeses. Zinc is a very reactive metal because it's very good at giving away its electrons to other people. In other words, all these other metals are higher than zinc metal, so we would call this a reactive, whoops, sorry, that's off the screen. We would call zinc a reactive metal. Or the other term for that is zinc is a really good, strong reducing agent. It's very willing to give away electrons to anyone who asks. So being up here means you're good at taking other people's electrons. That makes you a strong oxidizer. Being in the bottom right corner means you're very good at giving your electrons to others. That makes you a good reducing agent.